Vertical curve over crest. Crest vertical curves are curves that connect inclined sections of roadway, forming a crest, and they are relatively easy to design. The principal control in the design of crest vertical curves is to ensure that minimum stopping sight distance or SSD is available throughout the vertical curve. All vertical curves should not be shorter than the established minimum over crest. This is governed by the sight distance requirements, but sometimes a case of riding may demand longer curves than the sight distance. Some designers prefer no vertical curve to be shorter than 300 meters. The minimum curve length was suggested by AASHTO or American Association of State Highway and Transportation Officials to be 8 times the velocity in kilometers per hour for a distance of meters. The vertical distance from the intersection of the straight grade line to the curve is equal to 1/8 of the product of the algebraic difference in grades and the length of the curve in stations. This is called the maximum correction. The rate at which the curve departs vertically from both tangent grade line is proportional to the square of the horizontal distance from the end of the curve. The correction at any intermediate point is obtained by number 1. Multiplying the maximum correction by the square of the horizontal distance between the near end of the curve and the point. 2. Divide this product by the square of 1/2 the length of the curve. The sight distance and the length of the curve can be related to each other in one of two ways. The first possibility is that the sight distance is less than the length of the curve. Alternatively, the length of the curve could be less than the sight distance. This is the illustration. Right of way. Railway right of way means a strip of land that is granted through an easement or other mechanism for transportation purposes. A right of way is reserved for the purposes of maintenance or expansion of existing services with the right of way. It is a right to make a way over a piece of land, usually to and from other piece of land. A successful freeway and expressway operations closes the roadway from direct access to adjoining property and some local roads or streets. If local traffic and land used are to be opened, it must be served by service roads originally planned as part of the main freeway. Frontage road shall be permitted to enter connecting cross streets only at a distance of at least 100 meters for rural road and 50 meters for urban conditions. So this table is the minimum right-of-way widths for rural and urban freeways at grade in meter. Stopping sight distance. Stopping sight distance is one of the several types of sight distance used in road design. It is a near worst-case distance a vehicle driver needs to be able to see in order to have room to stop before colliding with something in the roadway, such as pedestrian in a crosswalk, a stopped vehicle, or road debris. Insufficient sight distance can adversely affect the safety or operations of a roadway or intersection. It is defined as the longest distance that a driver could see the top of an object 15 centimeters above the road surface where the design height of the driver's eye above the pavement is 105 centimeters. Stopping distance is made up of two elements. Number 1. The distance traveled after the obstruction or object is seen and before the driver applies the brakes. 2. The second distance is consumed while the driver applies brakes for the vehicle to stop. The distance covered could be expressed by the following formula. D equals T m over S. Braking distance D is equal to meter per second square over 2 GMF, and D is equal to meter per second squared over 19.6 F, where m over S is equal to initial speed in meter per second. T is detection, recognition, decision, and response initiation. GM is acceleration of gravity, 9.80 meter per second squared. F, coefficient of friction between the tire and pavement. The highway level being flat is assumed by the preceding formula. The braking distance is decreased when traveled uphill, while it is increased when traveling downhill. The following formula can be used to express the braking distance on slopes. braking distance is equal to D is equal to braking distance, or M, is equal to D is equal to meter per second square over 19.8 times F plus G, where G is the longitudinal slope of the roadway, or percent grade, or 100. Uphill grade is positive while downhill grade is negative. So this table shows the minimum stopping sight distance wet road. The passing sight distance. Passing sight distance is needed where passing is permitted on two-way highways to ensure that passing drivers who use the lane normally reserved for opposing traffic have a sufficiently clear view ahead to minimize the possibility of collision with an opposing vehicle. The distance includes the distance traveled during the perception or reaction time and the distance traveled while accelerating to the passing speed. It is the longest distance that a driver can see the top of an oncoming vehicle where the driver's eye level is 1.05 meters above the pavement surface. The relationship between the passing sight distance, the algebraic difference in grades, and the length of vertical curve is represented by the following equations. L is equal to 2S minus 943 over A, where S is greater than L, and L is equal to AS2 over 943, where S is less than L, and L is length in meters. L is equal to length required of vertical curve, and S is specified sight distance. A is algebraic difference in grades expressed in percent. The design of two-lane highway of passing over crest is generally practical only on flat grades because the longer vertical curves are required to provide passing sight than stopping sight distance. F is equal to meter per second square minus SE over 9.8 rm, where meter per second is equal to meter per second, and rm is equal to radius in meter, SE is equal to super elevation. At 75 km per hour, the maximum coefficient of side friction on dry pavement, as determined by curve testing, is approximately 0.35 for smooth tires and 0.4 and 0.5 value with normal pavement. The two table shows the AASHTO minimum passing sight distance for design of two-lane highways and AASHTO recommended maximum coefficient of side friction. Road alignment. The alignment is the route of the road, defined as a series of horizontal tangents and curves. The profile is the vertical aspects of the road, including crest and sag curves and the straight grade lines connecting them. It should be consistent. An abrupt change from flat to sharp curve and long tangents followed by sharp curve should be avoided because it will create hazard and invite accident. There are two types of road alignment. One is the horizontal alignment and two is the vertical alignment. Horizontal alignment, it includes straight stretches, curves, etc. While vertical alignment, it includes upward or downward gradients. And lastly, this is an example of both alignments.